2 for our differential equations review. All right, so I'm going to pick it up with number 9. We have a curve that has a slope of 2x plus 3 at each point on this curve. All right, so when it says it has the slope, that is telling me that our y prime or our dy dx is going to be 2x plus 3 at every point. Okay, so we're going to find an equation for this curve if it passes through the point 1, 2. So I'm actually going to do the antiderivative to find letter y. All right, so the antiderivative of 2x is x squared. Antiderivative of 3 is 3x. I'm going to put plus c. Okay, and to find that letter c, I'm going to plug in for x, I'm going to plug in 1, and for 2, for y, I'm going to plug in 2. All right, so then solve for c. So I got 1 plus 3 plus c, so that's 4. So 2 minus 4 is going to be negative 2. So the answer is x squared plus 3x minus 2. Okay, number 10. All right, so it says, which of the following differential equations would this function be a solution to? All right, if you notice in A, B, C, and D, all 4 answer choices have y double prime and y prime. So I need to find the first derivative and the second derivative of this original y function. So I'm going to copy down e to the power of 3x. The derivative of 3x is going to be 3. Derivative of negative 5x is negative 5. So that's the first derivative. Second derivative, copy down e to the 3x again. But then we need a derivative of 3x is 3. There's already a 3 there, so 3 times 3 gives you 9. Derivative of a constant is 0. All right, so let's plug this in. I'm just going to start with option A. If that works, great, I'm done. If not, I go to B, then C, then D. All right, so we have y double prime, so 9e to the 3x power, minus 3 times our y single prime, which is 3 times e to the 3x power minus 5. And then, minus 15 equals 0. So copy down 9 times e to the power of 3x. Distribute, so that's minus 9 times e to the power of 3x plus 15 minus 15 equals 0. If you go left to right, you'll see the first 2 terms are going to make 0. Then the last 2 terms make 0. So actually, option A is our answer. All right, number 11. Okay, it says, what are all solutions to the differential equation dy over dx equals 1 over x times the natural log of 2? So again, this one, the thought is like this is y prime, right? I'm going to order this a little bit differently since the natural log of 2 is a constant. All right, so I put times 1 over x. All right, and then if I do the antiderivative, right, remember the idea is if I have a constant, I can just copy down the constant. All right, and then the antiderivative of 1 over x, and I'll show you guys in class, this is x to the negative first power. That's going to be times the natural log of the absolute value of x. All right, and we have our big giant plus c at the end. So if you put those together, right, you'll have the natural log of x divided by the natural log of 2, which you'll see gives us answer choice A. Okay, let's go to number 12. All right, so number 12 is a little bit different. I know the wording seems similar, but in number 12, you'll notice on the second part, or after the equal sign, that we have x and y. So to do this, I'm going to reorder this by moving the y and the 4 to be over with dy. So that's dy times 4y. And then move the dx to the other side. So x times the cosine of x squared times dx. So now if I take the antiderivative, right, this is going to be y squared. If I take the derivative of y squared, I get 2y, but I want 4y, so I'm going to put a 2 in front. All right. This one is going to be a little tricky. If I put the sine of x squared, right, do the antiderivative, the sine of x squared, the derivative of that would be cosine x squared, so I've got that. But the derivative, right, chain rule says I have to take the derivative of x squared, which would be 2x. I just want 1x, so I need to put a 1/2 in front to make sure that that ends up being just 1x. Okay, I'm going to put a giant plus c here on this right side. I'm going to solve for y. So I'm going to move the 2 over with division. That gives me 1/4 sine of x squared plus c. And then take the square root of both sides. So I have the square root of 1/4 times the sine of x squared plus c. All right, now this is the answer. You'll notice when I start looking at my answer choices that it's a little bit different because they've gone ahead and, oh, I'm sorry. This is the answer. That is one of my answer choices. It is B. What I was going to say is they're trying to trick you because the square root of 1/4 is 1/2. All right, so like when you look at answer choice A, you might be thinking, hey, that is the answer. But notice in my actual answer, you'll see that this plus C is underneath the radical. So that's kind of a giveaway. You'll notice here the plus C is not inside the radical. So kind of remember those kind of things. All right, so 12 is B. 13. All right, very similar to what we just did. We want a general solution. So I notice on the right-hand side, I've got the square root of y that I can factor out, right, which is going to be 1 minus the sine of x. And then I want to move the y to be over with the dy. So that's dy over the square root of y equals 1 minus sine of x times dx. Now, there's a lot going on here. I've got the square root of y, which I know is y to the 1/2 power, and it's in the bottom. So that's really y to the negative 1/2 power times dy. And if you remember from the end of the first semester, early second semester, to find the antiderivative, I'm going to add 1. So negative 1/2 plus 1 is positive 1/2, right? But when I take the derivative of y to the 1/2 power, I would actually need to write 1/2 in front times y to the negative 1/2 power. And I don't want that, right? So I need to put the reciprocal in front, so 2. All right, let's do this one here. All right, if I do the antiderivative of 1, that's going to be x. And then if I write cosine, right, if you remember from our days of derivatives, the derivative of cosine is negative sine x. So actually I'm going to write plus cosine, because if I take the derivative of cosine, I'll get negative sine x. All right, and then plus c. All right, so let's move over the 2. All right, with division. So 1/2 x plus 1/2 cosine of x plus c. And then square both sides to get rid of that 1/2 power. So I'm going to have 1/2 x plus 1/2 cosine of x plus c, all of that squared. Now, this is the answer. When you look at your solutions, you're going to see that you're really in between, probably seeing we're in between C and D. And they got the 1/4 by squaring the 1/2. But the key thing, like I mentioned in number 12, is that you'll notice in my answer that I wrote, the C is inside the parentheses that's being squared. So just kind of keep that in mind, right? That the C needs to be, the constant is inside the parentheses there. So 13 is D. Just a few more. Let's try 14. What are all the solutions to this differential equation? Again, when I look on the right side, if I don't see the letter y as well, I'm just going to think of this as just strict antiderivative problem. All right, so I'm looking at to do go backwards from secant squared. And I know it's been a while. I'll show you the formula sheet again in class. But the derivative of tangent of x is secant squared. So that's why it is letter A. Okay, 15. All right, so 15, all right, is a particular solution problem where it's all very similar to the work we've done so far in this video, but now they're giving us an initial condition. All right, so there'll be a little bit more work at the end to make sure I get my particular solution so we don't have a plus c here. All right, so I'm going to move this y to the other side, so to get dy over y equals cosine of x, and move the dx over, so times dx. All right, so this is really y to the negative first power times dy. And as we've done in class and in some other example problems, when you take the integral of something raised to the negative first power, that is the natural log of the absolute value of that, whatever it is, in this case, y. Okay, equals, if I go backwards from cosine, I get sine, right? The derivative of sine is cosine, so that's good. Do your plus c. Now, what we did in class to deal with this is we took both sides and we did the natural exponential function of both sides. So I did e to the natural log of the absolute value of y equals e to the sine x plus c. All right, so this just becomes the absolute value of y, which I'm going to take away now, is equal to e to the sine of x plus c. All right, so this is my answer, but because this is a particular solution, I'm going to plug in my initial condition. So when I plug in pi over 2 for x, I get y is e. So y is e when I plug in pi over 2 for x. All right, it's been a long time since we've done this, but the sine of pi over 2 is going to be 1. That's e to the first power. All right, so if I move that e to the first power over, I get c equals 0. So the answer is just going to be this, but where c is 0. So it's y equals e to the sine x power, so letter D. Okay, let's try 16, and then we'll be done with this part. All right, so they're giving us a differential equation. All right, so that's not a D, dh over dt equals 2 times h plus 1. All right, and they want us to find which of these must be true. Okay, so very similar, it's just a little confusing because we're not using y and x. So I'm going to move the 2h plus 1 to this side and move the dt over there. Okay, and like I said before, if you rewrite this as like 2h plus 1 to the negative first power times dh, you'll see very similar to what we did in 15, that it's the natural log of the absolute value of 2h plus 1. All right, and then if we do the integral of dt, we get just t plus our constant. So actually, this is as far as you need to go in this answer choice. They're not making you go any further. So in this case, we're going to pick answer choice C. All right, so that's it for part 2. Tune in for the next part.